Welcome to another video of Code Snippet, and this is going to be the one-shot video where we will look into resilience and fault tolerance patterns. We will see what exactly is resilience and fault tolerance inside microservices, and after that we will look into different patterns by using which you can make your microservices resilient and fault tolerant. So let's get started without wasting any time. This is going to be another fun video, so sit back, relax and enjoy the show. Alright, so let's quickly jump into the agenda of this particular video. So resilience and fault tolerance patterns in one shot. So this is basically the big picture that we are going to cover in this particular video. So first we will look into what exactly is resilience, what exactly is fault tolerance inside microservices in first place. So we will segregate each topic into different sections and we will look into each topic separately. We will try to understand each topic separately. First, we will see resilience and fault tolerance inside microservices. We will understand different nuances of resilience and fault tolerance. After that, we will get started with different patterns. So these are basically the essential patterns that we are going to look into in this particular video along with the demo of each. So first we will look into retry pattern. After that, we will look into rate limiter pattern by using Resilience4j. So Resilience4j is a famous library that is used in order to implement all these features inside microservices. After that, we will look into rate limiter, we will look into circuit breaker, we will look into time limiter, and we will look into the BulkHead pattern. So these are essential patterns in order to make your service resilient and fault tolerant. So that is basically the simple agenda. So let's get started. So resilience and fault tolerance in microservices. Very important concept inside microservice. So first we will see the reality of distributed systems. And after that we will look into what exactly is resilience, what exactly is fault tolerance. And we will see what are the common cases when microservices fail and why exactly microservices fails. After that we will see what exactly are cascading failures. We will see how we can build resilient systems. After that, we will have quick introduction to resilience patterns. What are different patterns by using which we can make our microservices resilient. And at the end, we will see the roadmap of upcoming videos on what we are going to look into as part of resilience and fault tolerance. So that is basically the simple agenda of this particular video. So let's get started. So what exactly is the reality of distributed system? So if I go back to canvas, then this is basically a simple microservice architecture where we have couple of microservices. So this is basically distributed microservice architecture. We have order service, we have inventory service, we have Eureka server. We may also have a API gateway, that also we have seen. Now usually what we'll have, client will call API gateway will call order service will call inventory service will send some data in response to order service. Some inventory related data will be sent. And by using that inventory related data, this particular order service will do its operation. So everything is working fine, happy scenario, right? But what will happen if inventory service suddenly fails? Now there is no inventory service. Order service wants to get some inventory related data from inventory service. But inventory service is not available, it is not operational, it may be down or it may not be giving some kind of response because it is getting some error inside the service. Maybe code related errors or memory specific errors can be there. So there may be multiple reasons why this inventory service might be failing. But now our friend order service is not getting response from inventory service. Now what will happen? Order service, since it is not getting any response, it will not be able to do its operation. And this guy also will fail doing its job. So now your order service will also not work. And that is basically the reality. You will definitely going to have failures inside your microservice architecture. It's not like there will not be any failure. There will definitely be failure and you need to be ready for all kind of failures inside your microservice architecture. So the truth is, in distributed microservices, failure is not a possibility, it is certainty. You will definitely have failures and that is why you need to be prepared for that. So in distributed systems, failures are not possibility, they are certainty and you need to be prepared for those failures. So that is basically the reality of your distributed systems and you need to be prepared for this particular failures of any of the services or multiple services or if something fails, your architecture, your microservice architecture should still be working. So that is basically something you should be aware of. So that is basically the reality of distributed systems. Now let's move ahead and look into what exactly is resilience. So let's say now inventory service is not working, right? Inventory service is not working anymore. And whenever order service is sending some request to inventory service, it is not getting any response. Now, if we are not getting any response from inventory service, order service should handle the response gracefully. Order service should not fail because inventory service is not returning the data. Order service should handle this scenario and fall back to some default implementation. And that is how order service can be resilient. So now what is resilience? The ability of system to recover from failures and continue operating. So in this case, your order service will still work, and even if your inventory service fails, order service is still working. It's just that it may go ahead and do some different job instead of doing a normal functioning, but it is still working. It is still up and running instead of showing any failures. So that is basically the resilience of your system. So ability of your system to recover from failures and continue operating is basically the resilience of your system. Your system may degrade in operation, but it will not completely fail. So your system should be resilient. After that, what exactly is fault tolerance? Now, fault tolerance is an ability to continue functioning even when a component fails. Now, here inventory service fails, but let's say inventory service have two instances and only one failed. But inventory service, the second instance of inventory service is still working, and your order service will function normally. In first case, in resilience, your order service was recovering from failures and continue operating, but it was not operating normally. It will fall back to some other implementation when inventory service is down. But your fault tolerance means your component entirely failed, but your system is still working correctly, functioning correctly, because your inventory service, the other instance of inventory service, will still serve the request and give the respective response to this particular order service. So that is basically your fault tolerance. So that is basically two things that you need to be aware of. So resilience and fault tolerance, very, very important stuff. So we have seen what is resilience and we have seen what exactly is fault tolerance. Now let's proceed and see few common reasons why microservices actually fail. Let's say you have many microservices running. Now, first common reason why microservices fail is basically issue inside network. It could be that your service is running on a cloud or on on-prem application where network errors can occur. It happens many times that your cloud provider will show that there is some kind of maintenance activity going on because of some issue at their end, and few network related stuff will not work. In that case, your microservices may go down. There may be connection failures or DNS issues which may occur inside any of your services. After that, second common reason, very common reason, is service crash. So your service can abruptly crash and few functionalities might not work. It could happen that your JVM is out of memory, or there is no memory on your server to do its operation. Null pointer exception, very common reason. Your Docker containers may go ahead and crash. So that is basically other reason. High latency. It may happen that your inventory service is taking a lot of time to process and delaying the request. For example, if order service sends the request and inventory service is taking forever to respond, in that case, it will add latency inside your request and it will make things worse. So your service is alive but responds after 20 seconds. So that is again a problem. After that, database failure. So your inventory service is connecting to a database, but this particular database crashed. Now inventory service is not able to connect to database. How it is going to fetch the data, the inventory related data from this particular database? It cannot, and since it cannot fetch the data from database, it cannot give the response to order service. So that is basically another issue. So that is why your services may go ahead and fail. So these are few common reasons why your microservices can just go ahead and simply fail. Now these are very common reasons and happens frequently inside production. So that is why your system should be resilient and fault tolerant. So that is basically why your microservices may fail. Next is cascading failures. So this is basically self-explanatory. So if your inventory service is down, order service don't know what to do, because the order service is dependent on inventory service. Now, since inventory service is down and not giving any response, order service will also stop working. Order service may throw some errors and may not even send any response to client. That is basically the problem. So that means your entire service stops working. So your inventory service becomes a single point of failure because all other services stopped working because of this inventory service. That is basically called as a cascading failure. So this is again very common stuff because this happens, right? If any of the service even if this database goes down, it may go ahead and inventory service stop working. After that, order service will stop working and everything stops working. So your entire system is dead. So that is basically cascading failure. It is pretty common and you should be aware of it. So now finally, let's see how we can build resilient system by using resilience patterns. So we say that failure are certainty, right? We will get failures in our microservice architecture. Then how these big companies like Amazon, Netflix, Uber make their system so reliable that many of the people use it on daily basis and the systems will not fail. How many times you have seen Amazon crashing? Almost never, right? So people are building it and people are building it on certain patterns. They follow certain patterns when they build microservice architecture, and that is when we need to look into resilience patterns. Very, very important patterns. So let's look into resilience patterns and what are different patterns available. So we will just have a quick glance at them and we will look into each one of them individually in separate video in upcoming videos. So first is basically retry pattern. So most of the times your failure may be temporary. For example, there may be like 1 second glitch inside the network in inventory service. Now, in that second only this particular request reached and this particular request failed. Now, you cannot just go ahead and fail your order service request. What you can do, first thing you can go ahead and try is retry again after a certain amount of time. I can just go ahead and send it after 3 more seconds, let's say. And that time the network was just fine and your inventory service just worked. That is basically your retry pattern. So retry gives a temporary failure a second chance. So by using retry, it may happen that the second time request just worked. So you need to try and retry, basically simple stuff. After that, circuit breaker pattern. Now let's say all the instances of your inventory service is down, but your order service keeps calling inventory service. One time retry will happen, like 3 times, let's say 5 retries are there. After that also it is still failing. Then few requests are still coming. The load on order service is normal. It is getting the request one after another, but inventory service is down. Now after some time as well, inventory service is down. If this guy is completely down for a while, why I am sending the request to inventory service? So what circuit breaker pattern will do, it will just go ahead and stop sending requests to a service which is basically down. And circuit breaker stops a failing service from bringing down the entire system just by stopping the request. So it will just open a circuit and your request will not go to inventory service. Rather than order service will fall back to a default implementation if the inventory service is not available. That is basically your circuit breaker pattern. So I'm just giving a brief idea about it. Each one of them we are going to look into in the upcoming videos. After that, time limiter pattern. So let's say this particular inventory service is taking like a minute to respond. Now 1 minute is a very long time, it's 60 seconds. Order service cannot just go ahead and wait for long. So there is a time limiter. So if I just go ahead and configure a time, let's say 5 seconds, this guy should give the response in 5 seconds. Otherwise order service will move ahead and handle the response gracefully. So that is basically your time limiter pattern. Time limiter prevents users from waiting forever. So that is basically time limiter. After that, you have fallback patterns. Fallback is basically something that we have been discussing. So if this particular service, inventory service, is entirely down, order service can have a default fallback on how to handle the failures of inventory service. Now fallback provides a graceful degradation experience. That means your order service will not fail. It will handle this particular failure of inventory service gracefully by using a fallback mechanism. So that is basically a fallback pattern. After that, we have BulkHead pattern. So let's say if one of the service is consuming all the resources. So let's say there are a couple of microservices running on same server and all the resources are basically consumed by one service. And other services not getting resources. Let's say there is a payment service which is not getting resources because this guy is getting all the resources. Now BulkHead pattern will isolate this particular service, isolate this particular failure service and stops this particular failure from spreading entirely inside your microservice architecture. Because if this inventory service is getting all the resources, it may happen that other services will not get any resources as well and may go ahead and fail. So BulkHead prevents failure from spreading by using isolating the failure. After that, we have rate limiting patterns. It may happen that your service is basically overloaded. That means order service is getting thousands of requests per microseconds and it is not able to handle that much amount of load. This guy is loaded, this guy is also loaded. This may be calling some other service that also will be loaded and everything may just go down because all the threads are occupied and you will get errors inside your application. So that is when rate limiter comes into picture. So it limits the incoming request and it will just reject the extra request, the extra load that is coming on your microservices. So rate limiter protects services from overload. That is basically something that happens. So these are basically resilience patterns, and by using these resilience patterns, we create a resilient services and fault tolerant services, fault tolerant microservices, and make our services rigid. So that is how people build resilient systems, by using these resilience patterns. And in order to do all this, Spring Boot have a famous library which is called as Resilience4j. Resilience4j is basically a famous library which has mechanism to implement all these patterns, and it is pretty easy and it is pretty fun as well. We will see that in upcoming videos. Our future roadmap is basically to cover all these. So in each video we will cover retry pattern, circuit breaker pattern, time limiters, fallback, BulkHead and rate limiter patterns. So all these patterns we will cover in upcoming videos. So those videos are going to be fun again. So we have seen building resilient systems, we have seen introduction to resilience patterns, we have had a brief about it. The detailed explanation and implementation we will look into the dedicated video, and we have seen the quick roadmap as well. So that is basically your resilience and fault tolerance inside microservices. Alright, so until now we have looked into the first section, which is resilience and fault tolerance inside microservices. Now let's get started with retry pattern and let's jump into this section. So retry pattern inside Spring Boot, in which we will look into what exactly is retry. After that, we will see how we can achieve retry inside Spring Boot. We will have a quick demo, and at the end we will see how it actually works internally, which is basically very important. So that is basically the simple agenda. So let's get started. Now the first thing is, why are we doing all this? Why are we having this retry pattern and stuff? Well, the answer is to achieve the resilience and fault tolerance system. What if something fails inside microservice communication? Now, what exactly is retry? Now, if I go over here, then we have this simple microservice architecture, right? We have order service, we have inventory service, and we have a Netflix Eureka server running. Now, when someone places the order service will receive it and it will try to check inventory inside inventory service. Once it receives the data, it will just go ahead and proceed. It will also go ahead and update the inventory after the order is placed. So that is basically the simple flow. Now, what will happen when this particular call just fails? If this particular call fails, then what will happen? This order service will not get any inventory. Now, if this order service is not getting any inventory, what will happen to that call? That call will just be broken, right? So that is basically a problem. There could be many reasons why this call is failing. It may be that inventory service is down, or it may be that it is failing, or it may be that there is kind of a network glitch or a temporary failure. If it is a temporary failure, there are high chances that when we retry it, it will work. What if it is just a simple temporary network failure? If we just go ahead and retry, it will just work. But we cannot keep retrying like infinite number of times, right? let's say inventory service is down and we are retrying from here. Now, no matter how many times you retry, the calls will keep on failing because this guy is down. So retry should have a limit. So you should retry only some number of times. So that particular configuration you should have. After that, let's say if I just call this particular service and it is failing and immediately I'm calling it again. It could be that inventory service needs like couple of seconds to recover from the failure, or if there is a network issue, the network issue might take couple of seconds to come back. Now order service should wait for, let's say, some amount of time before making a next retry. So that is basically called as a back off. That is basically another use case. After that, let's say this particular inventory service is throwing some kind of exception. Let's say it is kind of a runtime exception, 500 error. Now 500 error is basically the failure of your inventory service. In that case, we might not need to retry because it might fail again. I only want to retry on, let's say, interrupted exception or socket timeout exception because it's kind of a network failure. Then I need a ability to retry on certain type of exception only as well. Our retry mechanism should have all those capabilities. So now if I need to implement this capability inside my order service, what I need to do? I will need to have a module which will handle all these retry. If this particular call fails, it will just keep on monitoring this particular call. If it fails, it will check for which type of exception this guy is giving. Then it will keep track of how many number of times we are sending this request. Again, it will handle the back off as well. That means before retrying, how much time it needs to wait, that also will be handled by this guy. So this particular module will handle everything. Now, instead of we going ahead and implementing this model inside our service, Spring Boot already implemented it inside a Spring Retry module. Now what we need to do? We just need to go ahead and use it. Now, that is basically your retry. So if I go back, that is basically your retry. That means retrying on a temporary failures, nothing else. Now, inside Spring Boot applications, you have two ways of implementing retry basically. First one is by using Spring Retry. So Spring Retry is something which is already present inside Spring Framework, so you can just go ahead and use it. Or second thing is basically Resilience4j library. So there is basically a library which you can add inside your Spring Boot application, which will help you to implement this retry. So in this video, we'll look into how we can make use of Spring Retry, and in the upcoming videos, probably we will have a glance at Resilience4j library, because all other things like circuit breaker, time limiter, fallback, and all those patterns we need to look by using Resilience4j. So here we will quickly look into Spring Retry. So those are basically the two ways you can implement Spring Retry inside your Spring Boot applications. Very, very easy stuff. Spring Retry is the easiest pattern for resilience, to achieve resilience. Now, let me go back to code. So now here, if you remember, we have a Eureka server. So Eureka server is basically running. We have inventory service, which is basically running. And we have this order service, which is basically running over here. Now, if you remember, we have this controller, we have this place order method inside which we are making use of a get call first of inventory. After that, we are getting quantity. We are updating inventory after placing the order, and we are reducing the quantity by 1. So that is basically our job. Now when we say get inventory, if this get inventory call fails, then we need to retry. Now here I have added another service, which is inventory service, and from order service I am just saying inventory service dot get inventory, where I am calling our fain client. So this is basically inventory client dot get inventory, which will call this particular inventory service and get the inventory for us. So this is basically the call. Now here I am explicitly throwing an exception in order to test. Now if we call this particular method, we'll just go ahead and fetch the inventory. But in order to test it, I am just throwing the custom exception. And now if I run this particular ecom order service, and let me just bring up Postman over here. So let me just pull Postman. There we go. And make this particular API call, which is basically place order. Then it will just go ahead and fail because our inventory service is throwing some kind of error. So we are just creating this particular issue inside inventory service in order to test. Now here, if you see this particular log calling inventory service for product ID. I will just copy it and try to look for it. So if you see over here, it is just printed only once. Now let's try to implement retry over here. Now in order to implement retry, what you need is you need three things. First, you need to add dependency. So this is basically for Spring Retry, right? Spring Retry. So first you need to add dependency. Second thing you need to do is add enable retry annotation on your configuration class. And third, make use of a retryable annotation. This is basically a Spring Boot annotation in order to retry inside your method. Now what I will do, I will just go to our POM, and here if you see, I have added this Spring Retry dependency. After that, you will need this particular AOP dependency as well, because our friend retry works on a proxy based approach that we will see when we actually look at the internal implementation. So this is basically the first thing. Second thing is you need to add a enable retry annotation on top of your main application class. And the third thing is, so now let's say this is basically the get inventory method, right? Now we want to add a retryable annotation on top of this method, because we are making a communication with our friend inventory service over here. What I will do, I'll just say retryable. This is basically retryable annotation, and retryable annotation will have some parameters. So if I go inside it and scroll down over here, then what do we have? You can give maximum attempts. Let me zoom it a bit so that it's clearly visible. So max attempts is basically maximum number of attempts, including the first failure. Default value is 3. So if you do not define anything, it will just try 3 times. After that, you can give expression as well over here. After that, back off means the delay. So before retrying your next operation, how much time you want to wait, that is basically can be defined inside your back off. And there is this retry for, which will tell on which exception I want to retry. So I will just go ahead and bring in all this. So retry for runtime exception, max attempt 3, which is basically the default value. And back off is basically 2 seconds, which is going to be my delay before sending the next call. And that's it. That is all you need to add on top of your method. On top of your method, that is all you need to add. Now what I will do, I will just quickly stop and rerun this particular application. Now let's see what happens. Let it come back. Now it has been started. Now let me just send the same request. Let's see what happens. Now what I will do, I will just go ahead and copy this particular log, and let me try to search for it. Let's see how many times it was printed. Now if you see, first time it is printed, this is second, and this is third. So it is basically being printed 3 times. That means it is doing 3 retries after 2 seconds. That is how your retry basically works, by using retryable annotation of your Spring framework. So here if you see, it is coming from Spring framework retry annotation retryable. This is basically retryable. And another way that I highlighted is by using Resilience4j library. That is basically the discussion for the other day. So this is how you can enable retry inside your Spring Boot application. So now we have seen the demo part as well. So we have seen what is retry, we have seen retry in Spring Boot, we have seen the demo. Now is the interesting part, which is basically how it actually works. Now let me go over here. Now let's say you have a service, and which service is calling your retryable method. Now here if you see, we have this get inventory method, and it is being called from your order service. Now both are Spring Beans, right? This is basically order service. So this service is basically your order service in this case. So let me just rename this guy to order service, and this order service is calling your method, which is this method get inventory, which is basically annotated with retryable annotation. Now this guy works on a proxy based approach. It is working on aspect oriented programming. So if you have seen my Spring Boot playlist, then there is a video which explains aspect annotation. Everything inside Spring works on AOP, aspect oriented programming, be it your at aspect annotation, be it at transactional annotation, all those things works on proxy based approach. And this guy also works on a proxy based approach. Now what will happen? Now the moment we say like enable retry and stuff, what will happen? When order service calls retriable, there is something called as proxy will come in between, right? So there will be a proxy, which is basically Spring proxy. It could be a CGLIB proxy or it could be a JDK dynamic proxy. There are two types of proxies. So it will be clear if you see the aspect video inside Spring Boot playlist. You will find the link in description as well. Now, this call is not directly going to retriable method. There is a proxy coming in between. And this proxy is handling all the retry and stuff. Now here in this proxy, you will have something called as retry interceptor, right? Retry interceptor. And this guy, what it will do now, this guy is fun. So what it will do, it will just go ahead. So your call will go to proxy. Inside proxy, you will have retry interceptor. What this guy will do, it will call this particular retriable method. And if any exception occurs, that exception will be thrown to this interceptors. And what this interceptor will do now, all the logic of checking number of retries, backoffs and delays, exception type is basically handled inside this retry interceptor. And this guy will call this particular retriable method again if the retriable annotation is given on top of this method and the configuration is properly present. That means this particular maximum attempt, delay and runtime exception. If all these things matches, it will call it again. Now what I will do, since it is running inside debug mode, let me just go ahead and send this particular request again. And now if I go over here, now this is basically your order service, right? This call is basically order service, and this is get inventory, and this is basically your get inventory method. Now in between these two, do you see this? What is this? This is a Spring CGLIB. Inventory service $$ Spring CGLIB. Now this guy is the proxy I am talking about. In between you will see 16 hidden frames. That means 16 different classes are going through. And after that it is reaching over here. Now there is this particular interceptor which is called as retry operation interceptor. Now here if you see, there is a method called as do with retry. That means this particular interceptor, where is that? This particular interceptor will have do with retry, and here it will do all these things, and here it will just go ahead and when it says invocable clone proceed, it will call this particular retriable method. Now here you will see different catches. So here you have throwable, exception and blah. A lot of things are basically cached, and it will just catch the exception and it will check if it needs to retry this particular method. Now if I just proceed to next step, and let me go ahead and proceed as well again. Now here if you see, it is coming inside this particular retry operation interceptor, and now it will throw exception and it will decide if it needs to call the retriable method again. And now if I proceed again, then it will wait for 2 seconds and it will just go ahead and go inside this particular get inventory again, because now it is this guy is going inside loop. Basically this interceptor is going inside loop. This particular method is not inside loop. This method is being invoked by this particular proxy, this particular interceptor present inside this CGLIB proxy. That is how your AOP basically works. So AOP is kind of a wrapper in front of your actual method, which will intercept your method. That means before calling your method, it will do a lot of things. So this is basically the way Spring will handle things. So this is basically proxy. This is something called as a Spring proxy. Simple stuff, right? Now this proxy, now if you have been following my videos, you will remember that I have directly made this inventory client.get inventory over here. Now if I do that, I cannot apply this particular retriable over here, right? Because I'm doing update operations over here as well. But what if I add this method, this particular method, entire method inside order service only? Why did I create separate service? Now if I have this method, retriable method inside a same class, then this proxy will not be created, because this proxy will only be created between two beans. Now this particular method is present inside another bean, right? Inventory service. Now this is inventory service is one service, order service is one service. Proxy will be created between two Spring beans it will not be created inside the same bean. So self invocation will not work. So if I have this method, this particular inventory service get inventory method inside order service itself, and if I do just like get inventory over here without making any service call, then your proxy will not be created. It will directly be a method call and your retriable will not really work. So you need to keep that in mind, that retriable should be invoked from some other service. You cannot just go ahead and do self invocation and call retriable, because your proxy will not be created and retriable will not really work. So that is basically the internal implementation. Simple stuff, basically. Very simple stuff. Retriable is very easy pattern and you can easily go ahead and implement this guy. Simple, right? Now let me go back over here. So we have seen that one as well. Now very important thing that I would like to highlight over here is, when we make use of retriable, we should retry only for idempotent operations, mostly for get requests, and should not really retry for post requests, because they are not idempotent. If we try it multiple times, it may just go ahead and harm your server. So the general practice is to make use of your retriable on idempotent operations or get requests only, because if you hit multiple times, if you hit get request multiple times, it is not going to harm your system. If you do post, then it will just go ahead and harm your system. After that, limit your number of retries. Don't just go ahead and do random retries over here. Have your maximum attempts. After that, have your back off, have your delay over here, because your service, inventory service, might take some amount of time to come back alive. So you should have this particular delay. Also retry for custom exceptions. Don't retry. So this is basically for testing. I'm doing runtime exception. You should only do it for transient failures, transient exceptions, and not for all exceptions. So those are basically general practices you should follow when you make use of retry pattern or retriable annotation. Alright, so now we have looked into retry pattern inside Spring Boot. So successfully completed looking into retry pattern. Now for the next topic, let's look into rate limiter inside Spring Boot. Now this time we are going to introduce a Resilience4j library. So let's get started. Rate limiter inside Spring Boot using Resilience4j. And this is what we are going to look into. First, we will see what exactly is the problem with too many requests. After that, we will look into what exactly is rate limiting. After that, we will see why do we need rate limiting in the first place. After that, we will see where does rate limiter sit in microservice architecture. After that, we will go ahead and implement a rate limiter inside our Spring Boot application. Implementation is very simple. After that, we will look into different configurations that we have along with rate limiter, and we will see fallback and error handling as well. What should we do if this particular rate limiting is being triggered? That means we are not able to send the request. In such cases, fallbacks and error handling comes into picture. So we will see that one as well. Now let's look into the problem with too many requests. Now if I go to canvas over here, then let's say this is basically my architecture, right? So we have a client, we have API gateway, we have order service, we have inventory service, we have Eureka server as well. We have seen this multiple times. Now let's say we are getting some orders on this particular order service and we are checking the inventory. Now let's focus on this inventory service now. Now let's say this particular inventory service only supports 100 requests per second, right? 100 requests per second. If we are sending 100 requests at a time, it is working just fine. But now suddenly what happens is, on this particular service, we are getting 10,000 requests per second. Now what do you think will happen to this particular service? Now this sudden increase in request is basically a traffic spike on this particular inventory service, which is basically a problem. Now this sudden traffic, what it will do? This sudden traffic spike, what it will do? What will happen because of this sudden traffic spike? The threads inside this particular service will start exhausting, because it only supports 100 per second and we are getting 1000, 10,000. CPU increases because the CPU cores are limited over here and we are sending a lot of load. So CPU will be increased, it will go to 100% pretty quick. After that, database connections will be exhausted. This particular inventory service will be connected to this particular database, let's say. Now these connections will start exhausting because of a lot of requests. After that, your service will slow down and at the end it will just go ahead and crash. Now if this guy crash, order service also will crash, then your entire microservice will just go down. So that is something which will happen if you increase the sudden traffic on your service, microservice. If the sudden traffic on your microservice increases, these are the problems you face, and your microservice will go down and take other services down as well. That is basically the problem with a lot of requests. So if you get too many requests, these things will happen on your service. Now that is when, in order to solve such problems, something called as rate limiting comes into picture. And what exactly is rate limiting? Rate limiting is something which controls how many requests are allowed within a specific period of time. That means within, let's say, 10 seconds, I only want 5 requests, for example. Within 10 seconds, if I only want 5 requests, then 6th request in that particular 10-second window will fail. It will fail saying that too many requests. So that is basically a rate limiter. That is basically rate limiting. Now, if the inventory service is not getting the extra request in the first place, it will never fail. Very, very simple, right? All these things will never happen because we are not overloading inventory service in the first place. So that is basically your rate limiting. Also, to visualize it, let's say we have a limit of 5 requests per second. And in that second, we are getting 5 requests. Then 5 requests will be simply allowed. But the 6th request in that 1 second will be rejected saying too many requests. After that, the quota will be refreshed on next second because this is per second now. In the next second, another 5 requests will be allowed. And after that, if another 6th request or 7th request is coming, it will just be rejected. So that is basically how rate limiting simply works. Simple stuff. So that is basically rate limiting. So we have seen the problem and we have seen the rate limiting as well. After that, why do we really need rate limiting? So why do we need rate limiting? So the first problem that we see is basically traffic spike. If the traffic spike happens, then all these problems will occur and your inventory service will go down. So in order to solve this problem, we need this particular rate limiting. So first is traffic spike. After that, there are attackers, right? So there could be kind of a DDoS attacks. So the group of people called hacker will try to attack on your system it will try and send too many requests and ultimately try to bring down your service. So if they send 1000 requests to your service, it will just go down because it does not really support that much amount of traffic. So again, in order to handle such attacks, so DDoS like request floods, we need rate limiting, simple stuff. After that, there could be some clients which are trying the request again and again. So let's say this client is sending random requests to your application, not knowing that what exactly is the purpose of that request and stuff. So there could be some clients which are badly behaving, and in order to handle such clients, what we need rate limiting because the subsequent request will be rejected. After that, there could be some APIs which are expensive and we want to rate limit them. For example, let's say few clients we want to give only 100 requests per second because they are using that particular expensive requests. Then in that case, we can make use of rate limiting again. Or there could be that there are different plans. Let's say basic plan, premium plan. In basic, we want 10 requests per second. In premium, we want 100 requests per second. So that is basically a simple use case where we will need a rate limiting. So for all these reasons, we need rate limiting inside our microservices, and it is very, very important when it comes to resilience and fault tolerance of your microservice. So that is why we need rate limiting. Now let's look into where does rate limiter sit in microservices. So if we go back over here, then here we can add our rate limiter at multiple places. For example, we say that API gateway is kind of an entry point of your application, isn't it? So we can just simply go ahead and add rate limiting here itself. For example, let's say if this is the rate limiter, we can just simply go ahead and add it over here. So the request from client will be rejected at API gateway end itself. So first place, you can add it inside API gateway along with authentication and another stuff because the API gateway supports rate limiting as well. After that, you can add it between inter-service as well. For example, let's say if order service is able to handle a lot of traffic, but inventory service is not able to handle, then what we can do, we can add a rate limiting over here. We can add rate limiting here inside inventory service, or we can add inside order service when we are calling inventory service. So it's up to service who wants to take that responsibility. Let's say order service is the only service who is calling inventory service. Then instead of adding this particular rate limiting inside inventory service, we can add it inside order service while calling inventory service, saying don't call inventory service more than 5 times in a second. So this logic will now sit inside order service. So rate limiting can protect incoming traffic, that means traffic coming from outside, or outgoing calls, that means traffic going outside of your service. That means you can either put it over here or put it over here. So what we are going to do, we are going to add this particular rate limiter inside order service when we are calling inventory service, and the implementation will be same. If you want to add it over here, you just move that logic here. If you want to add it inside API gateway, you just move your logic inside API gateway, right? We have seen what exactly is API gateway as well, and we have that inside our microservice architecture. But how we are going to implement that is going to be pretty same. So that is basically where does your rate limiter sit inside microservices. So we have seen that one as well. Now let's quickly look into how we can implement rate limiter inside Spring Boot applications. And let me go back over here. Now this is basically our Eureka server, which is up and running. Here if you see, it is running. Again, we have this ecom inventory service, which is again running over here. This is basically ecom inventory service. After that, we have ecom order service. And where do we want to put this particular logic? We want to put inside order service. So let's go to order service over here. And if you remember in the last video, we have added this particular inventory service, and here what do we have? We have this retryable. So we were looking into retry pattern. Now while calling this get inventory, we will add rate limiting. So what we can do over here, first thing we need a library. Now there is a famous library which is called as Resilience4j, which will help you to add this particular rate limiting. So first thing you need to do over here is go to your pom.xml and add Resilience4j Spring Boot 3, or depending on what version you are using, you need to add this particular dependency and reload your maven. Once you add this particular dependency, you will have access to some annotations. For example, here if you see, if I say add the rate limiter, this is basically the annotation, and you can give some simple name like this. You need to give some name similar to this one. Retryable, we have this particular rate limiter as well. But if you observe the difference between this particular rate limiter and this retry pattern, then rate limiter is coming from GitHub Resilience4j, and retryable is coming from Spring Framework retry annotation. This is a part of Spring Framework, Spring retry library, and this is a part of your Resilience4j library. There is a retry in Resilience4j as well. So if you go ahead and say at retry, then if you see over here, now this retry is coming from your Resilience4j library. Now in the last video we have seen Spring retry retryable, but you can make use of this retry annotation as well, which is coming from Resilience4j, and it works in a similar way. But now that is not the focus for this video. You can simply go ahead and make use of that. The configuration parameters will be similar. There may be a difference in name or two, but the idea is pretty similar. It's just that you are using different library, which is Resilience4j, in order to do that. Now what will happen, right? Now let's say we are sending a request to inventory service. What will happen if that request is rejected? If that request is rejected, what should happen? How do we handle the rejection? So in order to handle the rejection, we have something called as fallback method. Now this particular fallback method, we just define it over here. And what we need to do, we need to add the fallback method inside this particular function. So if you see, this is basically, this fallback method over here is basically the name of other function present inside the same class. Now if this particular request is failed, this method will be called. Now what I will do, I will just go ahead and let me just stop and rerun this particular application. Let's see what happens with these many of the changes, right? So here I've just added rate limiter, and after that I'm just adding a simple fallback, nothing else. Now if you see over here, my application is started. So completed initialization. And now what I will do, let me just go ahead and bring up my Postman. There we go. And now if I just go ahead and send this request, then we are getting order placed successfully. If I send another request, we are getting order placed. We will keep getting order placed successfully. And if I go back and try to look for this particular log that we have added to see if any fallback was called. So let me just try to find it, and you will see that it is not called basically. That means our rate limiting is not coming into picture. So what exactly is the problem? The problem is we have just added a annotation and we never told the configuration part. That means how many times you want to call, how many requests should be allowed in that particular time window. That is something we never told this particular rate limiter, and that's why it is allowing all the requests, right? So that is basically the problem. So what we need to do, we need to see, this guy is basically suggesting us. So what we need to do, we just need to add this particular configuration inside our application YAML, and here you will have these particular fields. So inventory service is basically the name of your rate limiter. You can see it over here, and we have 3 configuration fields over here. First is basically limit for period, next is your refresh period, third is your time duration. So now your limit for period is basically, let's say 2 requests per second or 2 requests per time period. Now since my limit refresh period, that means my time period is 10 seconds, then this become 10 seconds. That means limit for period is basically number of requests and refresh period is your actual period. Now here we allow 2 requests per 10 seconds. This is basically the definition. After these 10 seconds are over, the quota will be refreshed and user can send another 2 requests. Another 2 requests will be allowed. So this configuration means 2 requests per 10 seconds. After that, time duration. That means, let's say if the request is rejected, how much time do I wait to get that particular connection? For example, if I go back over here, now let's say my request is rejected. Now it could be that after 1 second, this quota will be refreshed. Now if this request wait for another 1 second, it may go ahead and be allowed, right? It may go ahead and be accepted. How much time I want to let this request wait before rejecting it? Now if you are putting this as 0, that means we are immediately rejecting this request. We are not keeping it, right? We are not letting it wait. We are not giving it any duration to wait. We are just immediately rejecting it if it is not allowed in that particular time frame. Now with these much changes, if I just go ahead and stop and rerun, let's see what happens. Now if I go back to Postman and let's try to send it, 1 request, 2 request, and if you see, third request become out of stock. Now if I go back and go to inventory service, and let me just try to copy this particular text now, and let me just try to find it, you will see that we are getting 1 instance. That means our fallback was called. And now since we are returning quantity as 0 from here, it went out of stock. So that is basically how your rate limiting simply works. Simple stuff, very simple stuff basically. And we have seen the fallback. So this is basically the part of fallback pattern that we have. So if something fails, go to this particular method. So that is basically your fallback, and that is basically your rate limiter. And this is basically the configuration that you need to keep in mind. Simple stuff, right? Very simple stuff. Now that is how you can simply implement this rate limiter inside your Spring Boot application or your microservices. So we have seen the implementation of your rate limiter. We have seen the configurations as well. These are basically the configuration part. And we have seen the fallback as well. We have seen this fallback. Now what I will do, let me just go ahead and quickly stop and rerun this guy in debug mode. Let's see what we are getting over here. So I will just remove this debug point and I will just keep a debug point over here. And let me just mute it and run so that it come back. The application is basically starting, and it is started. Now let me unmute and let me send the request. So first request I will send, second request, and third request, it is coming on fallback method. Now here if you see, what do we have in throwable? So let me just open this, and if you see the error, it says request not permitted. Rate limiter inventory service does not permit further calls. So that is basically the error you get. Now similar to your retry, we have seen the internal working of retrieval, right? This particular rate limiter works on a proxy based approach. So here if you see, between your order service and inventory service, a proxy layer sits in between, which will handle this particular rate limiting for you. And something like that we have already seen in the last video in the retry. So let me just quickly find it out for you. So here this is related to retriable, right? In the similar way, your rate limiter also works. So this is basically a rate limiter method now. Spring proxy will come in between and it will just intercept this particular call and provide you the rate limiting related feature. So basically everything works on a proxy based approach inside Spring Boot. So that is how this particular proxy works, and it will throw you the required error as well, and you can handle this particular error in a way that you want. So this is basically the error it will throw, which says inventory service does not permit further calls. Now if you see over here, this particular rate limiting, it works on a different algorithms. For example, we have fixed window, sliding window, token bucket and leaky bucket. These are basically the algorithm based on which this rate limiting basically works. So these algorithms are basically very simple, and multiple libraries make use of multiple algorithms. It's like we don't have option to configure different algorithm over here. For example, if you see over here, we don't really have much. We only have fallback method and name. So we cannot just really go ahead and configure the algorithm. For example, if you want token bucket, leaky bucket, there are different libraries which will provide that. For example, BulkHead4j is the library which will provide these, right? And this particular library that we have, this is basically a Resilience4j library, right? So Resilience4j basically make use of a cycle based algorithm. So it is basically a cycle based rate limiting algorithm, which is pretty similar to fixed window. So Resilience4j uses cycle based rate limiting mechanism. Time is divided into refresh periods and a fixed number of permissions is available for each period. For example, let's say we have period of 10 seconds, right? So 0 to 10 second is basically one period and we have 5 permissions. So if you are getting 5 requests, then you will assign the 5 permissions to 5 requests and the 6th request will be rejected. This is basically your one cycle. After the end of this cycle, another cycle will come through and your permissions will be refreshed from 10 to 20 second and it can be assigned to another 5 requests. Again, if the 6th request comes, it will just be rejected. So that is how your cycle based rate limiting mechanism works, and it is pretty similar to your fixed window mechanism. After that, you will have sliding window, token bucket, leaky bucket. These are basically another famous algorithms in order to do your rate limiting. But our Resilience4j make use of this particular algorithm. It is very simple algorithm, and our Resilience4j basically uses that. So that is how your Resilience4j library will make use of this particular algorithm. Simple stuff. So we have seen this particular rate limiter as well. Very simple stuff. If you want me to explain these algorithms in more detail, let me know in the comment section. I can just go ahead and create a simple video on that one as well. So that is basically it for this particular video. So we have seen everything in this particular video. So rate limiter is also done. If you see over here, we have seen the retry pattern and we have seen the rate limiter as well. Now, another point I wanted to mention over here is that rate limiter and retriable. So we have both these over here, right? So if you think logically, rate limiter should come before retriable, because if there is a rate limiting applied, why will I go ahead and retry? Logically, before you perform retry, you check if the rate is limited on this particular service call. If the rate limiting is present, then don't do retry, basically simple stuff. Or if any other pattern is basically present, don't do retry, because retry should come at end. So we have seen rate limiting inside Spring Boot by using Resilience4j. So we have completed rate limiter inside Spring Boot. Now let's get started with circuit breaker inside Spring Boot. Again, circuit breaker we are going to implement by using Resilience4j. So let's look into different topics that we are going to cover in this particular section. So circuit breaker inside Spring Boot microservices using Resilience4j. First, we will start with a problem. So what exactly is the problem that this particular pattern is trying to solve? After that, we will see what exactly is circuit breaker. We will see why do we need a circuit breaker, and we will see different states that are present inside circuit breaker pattern. After that, we will look into the implementation and configuration, different configurations that are needed in order to set up your circuit breaker. At the end, we will see a quick demo, and that is basically the simple agenda. So let's get started with the problem. So if I go to Canvas over here, then this is basically our setup, right? So we have this particular order service, we have inventory service, we have Eureka server. Even before that, what do we have? We have API gateway, and client will send kind of a request. Now order service need a inventory data from inventory service. So it will just go ahead and request that. Inventory service will take the data from database and send it back to order service. That is our simple flow. Now we have seen retry pattern, we have seen rate limiter, everything makes sense. But what if this particular inventory service is down? Now this guy is down, and if this guy is down, order service will keep on sending the request to inventory service. So now order service is sending this request, and this request is failing because our friend inventory service is down in the first place. Now let's say user is sending 1000 requests from here. This particular order service supports 1000 requests, and client is sending 1000 requests, and all the 1000 requests are going to your inventory service, and all 1000 requests are basically failing. And now imagine within that we have a retry mechanism over here. Now if one request fail, what do we do? First thing we do is our first instinct is try to retry. What we will do, we'll send another request which will again fail. We will send third request which will again fail. So retry is not making any sense over here because inventory service is basically down in the first place. If this guy is down, no matter how many times you are retrying, every call is going to fail. So that is basically the problem. Now what will happen if we keep on sending this request? On each request, we will need multiple resources. Each request that we are sending over here needs resources. When I say resources, it will consume your thread of your order service. So those are basically the resources. After that, there will be network connections. So we are sending this request, we are making this REST calls, which will consume network connections, again basically consuming resources. After that, your order service is running somewhere, so that will go ahead and consume the CPU of your order service. Whenever we are deploying order service, the CPU will be consumed, so again those resources will be consumed. Now imagine you are getting 1000 requests and you are retrying 3 times. 3000 requests unnecessarily you are sending to inventory service, which does not really makes any sense. So that is basically the problem. If the service itself is down, we are sending the unnecessary requests, and all those requests are going to fail. So what do we want? We want a mechanism to know that inventory service is down. If order service knows that dude, inventory service is down, then order service can just go ahead and stop sending all these requests to inventory service. So all these requests will not be sent in the first place, saving the resources, the energy, the time inside this order service. So something like that needs to be done. Now, who is going to tell this order service that dude, inventory service is down? Who is going to tell this guy? There is no third person over here who is going to tell this order service that dude, this inventory service is down. That works needs to be done by order service itself. Now how order service can do? If I want to design this solution, how I can do that? So let me just pull this guy a bit down over here. Now what I can do, I can just simply go ahead and add a utility inside order service, let's say. And what that utility will do, that utility will keep on checking the calls to our friend inventory service. So it will check the calls to inventory service, and it will check the calls, let's say, in a 10-second window. So it will just keep on checking the calls, and it will check how many calls within these 10 seconds are failing. So if we are sending, let's say, 10 calls inside 10 seconds, then it will check how many calls are failing. Let's say 5 calls are failing. Now, what we can do now in this utility, we can just go ahead and tell this guy that dude, if 50% calls are failing, if let's say 50% calls are failing, 50% calls, if they are failing, what we need to do? We need to stop making calls to inventory service, and we need to handle it inside order service. Let's say 50% calls inside 10 seconds are failing, then we can assume that inventory service is down, or there is an issue with inventory service because major calls are failing, and we need to stop sending calls to inventory service. and we will stop these calls for next, let's say 10 seconds. For next 10 seconds, stop sending call. Don't send any calls to your inventory service. Don't send any calls up to next 10 seconds. And after 10 seconds, we will again re-evaluate. Probably we can send, let's say 5 calls again and see if they are working. If these calls are now working, then we can assume that inventory service is back and up and running. Then we can go ahead and send all the calls to order service and again keep on monitoring this cycle. So this utility will keep on doing all this. So this is how I would design a solution. I can just go ahead and add a utility inside this particular order service. But again, Java people knows about this issue already. They know about what exactly is circuit breaker pattern. So they have added this utility already. They have added this utility, and that utility we call as a circuit breaker. And now, in order to solve this problem, this particular utility, or we call it as circuit breaker, comes into picture. So we have seen the problem, right? Now we'll see the definition of circuit breaker. Now circuit breaker stops sending requests to an unhealthy service after repeated failures. Very easy stuff. Very easy stuff, right? Circuit breaker stops sending requests to an unhealthy service after repeated failures. That means in 10 seconds, 10 calls we are sending, 5 calls failed, 50% failed, then stop sending the request to inventory service considering it is down. Very simple stuff. And that is basically the definition of circuit breaker. So circuit breaker definition we have seen. Now again, why do we need circuit breaker? So first of all, why do we need circuit breaker? As we have seen over here, in order to save resources, right? All these resources we want to save. There is no point in calling an unhealthy service repeatedly. So in order to save resources, I'll just make use of this over here, save resources, first thing. After that, let's say if you don't do this, then inventory service goes down. It may go ahead and take down order service as well. So this is basically very basic of your resilience. That is something we call as cascading failure. So to avoid cascading failure, prevent cascading failure, we do this. After that, by using circuit breaker, we do faster failure detection. We detect that this particular service is down and we fall back. We make use of a fallback mechanism instead of sending the request to inventory service. How cool is that? So that is again another reason why we need circuit breaker. After that, we want to protect downstream services. We want to protect this service from going down because of this service is down. So that is another reason. It is similar to preventing cascading failures. And at the end, we want to improve the system stability. We want to improve system resilience, fault tolerance. That is the reason we need circuit breaker as well. Simple stuff basically. That is why we need circuit breaker. So now we have seen our simple solution, but let's see how circuit breaker solves the problem. And that is when something called as circuit breaker states comes into picture. So we need to understand different states inside circuit breaker. It's very simple. So if I go back over here, then this is basically how it looks. Now here, if you see here, majorly you see 3 states. First is closed, second is open, and third is half open. Now, it is pretty similar to your electricity analogy. That means if you connect 2 wires, that means if you close 2 wires, that means the current is flowing. That means your services are communicating. Simple stuff. Closed means your circuit is closed. That means it is flowing. The current is flowing. That means your requests are going through. Open means circuit is open. Now, if this particular circuit is open, how the requests are going to flow? That means we are stopping the operation. It is also marked as red color, marked in red color as well. That means open means when your circuit is in open state, that means the operations are stopped. The requests are not going to your other service. The communication is stopped. And what is the half open state? Half open state is basically when your service, when your order service is checking that inventory services came back or not. That means it is just trying to send, let's say 2-3 requests and checking if it is back or not. That is basically the state we call as half open state. Now what we will do, let's say everything is working just fine. The circuit is closed. Now we will check if in the 10 seconds, 10 calls, we send 10 calls, and we will check the threshold. Let's say 50% is the threshold. If 50% threshold limit is reached over here, then we will move to open state. Then the circuit will be moved from closed state to open state. After that, after some amount of time, it will go ahead inside a half open state and it will check if the inventory service is back up by sending few requests. If the request again fail, it will again go back to open state. But if the request pass, request successful with threshold limit, then your circuit will go back to your closed state. That means the requests are flowing again. So very simple stuff. Basically, if you understand this diagram, you will be able to understand it very easily. So that is basically different states inside your circuit breaker states. So we have seen that one as well. Simple stuff. Now let's jump into implementation, configuration and demo part. Now, if you remember, we have these three services. First, we have Eureka server, which is basically running. We have inventory service, which is again running. After that, what do we have? We have ecom order service, which is again running. If you see over here, all the services are basically up and running. And if you see over here, we have this inventory service, which is sending the request to your inventory ecom inventory service by using a Feign client. So our inventory client is basically Feign client, and we are trying to get the inventory from here, right? We have seen this multiple times. And in the same example, we have seen rate limiter. We have also seen retriable. So all these things we have seen in the last videos. So probably what I will do, I'll just go ahead and comment these guys for now, so that we can just go ahead and focus on our friend circuit breaker. We have a simple get inventory and fallback method, but we are not using that. Let's see over here. Now let's go back over here to ecom inventory service. Now here, if you see, our ecom inventory service is running. So what we can do, probably we can check the scenario where our friend ecom inventory service is completely down. Before that, what we need to do is we need to implement circuit breaker, and the implementation of circuit breaker is pretty similar to rate limiter. Circuit breaker is coming from the same library. Which library? This particular library, which is Resilience4j. So if I go back to pom.xml, then you need to add this particular Resilience4j dependency. Once you add that along with this AOP, once you add that, you will be able to access rate limiter as well as circuit breaker. Now, how you can implement circuit breaker? You can just say, let me just press enter over here. I can just say circuit breaker from Resilience4j. I will just give it some name and fallback method. Here I will just give it a unique name. Let's say inventory service circuit breaker. So that is basically circuit breaker and circuit breaker fallback method. Right? So that is basically the name that we give over here, and we'll just replace this name over here as well. And that's it. That is basically simply how we implement circuit breaker. Now what I will do, I'll just go ahead and restart this particular order service. Let's see what happens. By this much of changes, we have not done any configurations yet. We are just adding a simple annotation, and let me see over here. So our application is back up. Now let me try to send this particular request. What we are getting product out of stock. Perhaps what I will do, I will just go ahead and fill up some stock. So I'll just add 50 inside our stock, and now I will just go back and send some order. So order will be placed. I will send it again, and if I go back over here and try to see if any fallback was called, so fallback method, I will just go ahead and check. So you will see that there is no fallback call. That means everything is just working fine because our friend is fine. Let me just stop order service over here. So I will just go ahead and stop this guy. So if you see, inventory service is basically stopped now. Now if I try to send this request, you will see that we are going inside this particular circuit breaker fallback method. Now what I will do, I'll just mute it and send. Let's see what happens. Now if I try to search this method, then you will see that there is this particular one fallback. Now here we have not defined anything. We have not defined after how many times we need to retry. So now what I will do, I'll probably go ahead and send another request. Let's see what happens. It is sending some internal server error, and now you will see that our fallback method was called again. So that is how your circuit breaker will work. But in order to fine tune, in order to configure what exactly is needed for your service, we need to add configuration. So that is when this particular configuration comes into picture. Now let's go back to application YAML. Now here, if you remember, we have done the configuration for this particular rate limiter. Now in similar manner, we will need to do configuration for circuit breaker. Now here, if you see, after rate limiter, I have added circuit breaker, and we have added inventory circuit breaker, or what was the name that we have given over here. So let me just copy that. This name should match over here. So this particular name of our circuit breaker should match with this configuration name over here. Now first we will have sliding window type, and the value is count based. Now there are two type of sliding window types. One is time based, other is count based. Count based will work on count, and time based will work on duration. Basically simple stuff. After that, once you give count based, you need to give sliding window size. That means it is going to check last 10 calls. How many calls in last 10 calls check. So what I will do, I'll probably go ahead and give it a value as 6. After that, minimum number of calls. It is very important now. These are the minimum number of calls until which your circuit breaker will not calculate failures. So circuit breaker won't calculate any failures until 5 calls. Now this is a safety check, because let's say your failure threshold is 50%. But inside this particular window, there are only 2 calls and one of them is failed. Now that becomes 50%. Now only on failure of one call, we need not go ahead and open the circuit. So that is basically the problem. And in order to prevent that, minimum number of calls we can give. So until 5 calls, this guy will not calculate anything. What I will do, I'll just keep it 1 over here. After that, failure rate threshold, let's keep it 50% probably. So that is basically the failure threshold. After that, what do we have? We have wait duration in open state. That means once the circuit is in open state, for 10 seconds, we do not allow any request to go to inventory service. After that, permitted number of calls in half open state. Now we have half open state, right? Now this is the configuration for this particular half open state. Now for this half open state, permitted number of calls 3, maximum wait duration is 5 seconds, and automatic transition from open to half open is true. That means after 10 seconds, circuit will be transferred to half open state, and this guy will check if within 5 seconds 3 requests are passing. Once those are passing, what this guy will do, it will move the circuit to closed state again. So that is basically how it works. Now what we can do, let me just go ahead and restart our friend order service with this much of configuration. Let's see what happens now. Now here, if you see, our service is up and running. And what I will do now, I will just go ahead and, so our inventory service was again down. So I will just start it and let's see what happens. So what I will do, I will just go ahead and add some inventory first. So this inventory is added. So now if I send this, then you will see order is placed successfully. Now what I will do, I will just go ahead and stop this particular inventory service. Right now, let's stop this inventory service and let's see how many calls. Now I can just go ahead and probably send few calls from here. So 5-6 calls I sent, and now you can see over here, if I try to look for fallback method called, then let's see how many times it was called. It was called many times basically. That means our circuit is basically open state, in open state. And now what I will do, I will just go ahead and start our friend inventory service. Now what I will do, I will just go back and try to send it. Now you will see product is out of stock. That is because we need to add this particular inventory. Even if I have added the inventory, it is still saying that product is out of stock. That means it is going inside this particular fallback method. It is still going inside this particular fallback method even if my inventory service is back. So it will do it for this particular amount of time. How much? It will do it for 10 seconds. And now if I send it, now let me try to send it. And now if you see, the order is placed successfully. Now the circuit is closed again. So now if you see, if I keep on sending requests, all the requests will be successful because our friend has moved the circuit in closed state. So that is basically how your circuit breaker pattern works. It is pretty tricky to demo it because everything depends on this particular second and stuff. So that is basically how your circuit breaker pattern works. We have seen the implementation and configuration, and we have seen the demo part as well. Simple stuff basically. Again, as we have seen multiple times, again, as we have seen inside Retry and as we have seen inside rate limiter as well, it works on a proxy based approach. So it will have a Spring proxy. So probably what I will do, I'll stop inventory service now, and let me just open this and let me send some request. So here if you see, do you see this? This is basically the proxy. So order controller, order service, inventory service, and we have this proxy over here, circuit breaker fallback method, which is present inside a proxy, inventory service CGLIB proxy, which is handling all this. You will see these hidden frames, which will have a lot of abstract methods which will handle this circuit breaker for you. So all these details that we have discussed, so if I go back over here, all these details inside the utility that we were trying to come up, all these utility related details will be available inside this particular 25 hidden frames, which are basically the internal methods which are supported by this particular proxy and used by this particular proxy. So that is basically how it works on your proxy based approach inside Spring AOP. It is pretty similar to what we have seen. Now another configuration we have over here is basically the type of exception. That means on which type of exception, which exception type you want to invoke circuit breaker. That means record exceptions. That means if runtime exception is coming from inventory service, then invoke your circuit breaker. Or if IO exception is coming or HTTP server exception is coming, then invoke this particular circuit breaker. But if illegal argument exception is coming, ignore this particular circuit breaker. So if this particular exception is coming, don't stop inside circuit breaker, don't move to open state. So those exceptions also you can make use of. So this is basically another configuration which you can make use of. So that is basically your circuit breaker. So let me just go back. So we have seen everything over here. So circuit breaker is basically very simple pattern. You can just go ahead and try it on your own and see how it basically works. So that is basically it about circuit breaker pattern. Now next, let's look into time limiter inside Spring Boot. Again, we are going to implement time limiter by using Resilience4j. So let's get started and let's look into different topics that we are going to look into in this particular section. So time limiter in Spring Boot microservices using Resilience4j. So first of all, we will look into the problem. So we'll see what exactly is the problem that time limiter is trying to solve. After that, we will look into what exactly is time limiter. We will see why do we need time limiter in the first place. After that, we will see the flow of time limiter on how it works. After that, we will see the timeout versus time limiter. And at the end, we will see the implementation, configuration and demo part. Alright, so let me move to canvas over here. This is basically the example that we have been looking into. So we have this client, it will send the request to API gateway. API gateway will send it to order service. Order service will call inventory in order to get some inventory. Inventory service will return the inventory details and order will be placed. Also, we will have a simple Eureka server where all these services will be registered. Very simple flow. Now we have seen retry. If this particular call failed, then we can retry. After that, we have seen rate limiter. If you are sending many requests, if you are sending multiple requests, then your service may overload and go down. After that, we have seen circuit breaker, where if this particular service is completely down, then what to do inside order service. But now, in all such cases, there was a problem with the service. Either it was going down, rejecting calls, or having some problems within. Now consider a scenario where everything is working. This guy is returning the response. This guy is also running. This guy is up and running. Inventory service is up and running. We send this request, but this particular response is taking a lot of time. This inventory service is taking a lot of time to return this response. And because of that, order service keeps on waiting for this particular inventory service to return the response. And it will consume a lot of time, and your client is waiting on the other hand to get the response back. it is a bad client experience. Your client is basically waiting. After that, since this particular order service is waiting for the response, the connection is occupied. This connection is occupied for that much amount of time. So that is again another problem. Your thread pool inside order service may get full if other requests are coming parallelly. If other requests are coming, then your threads will be occupied and your thread pool will get exhausted inside order service. And all that is happening just because your inventory service is not returning the response in time. So that is a problem that we face inside microservice communication. Now, again, if I want to solve this problem, how I can solve this? How I can solve this problem? I can easily solve this problem inside this particular order service. What I can do when I send the call to inventory service, what I can do? I can just simply add a utility, and when I'm calling this particular order service, I can simply add a timer. I can add a timer inside your order service, right? A simple timer. Second thing I will do, I will just go ahead and configure some time. Let's say, so I will just go ahead and configure some amount of time. And if this particular request is taking more than this time, then what I will do, I will stop this request, I will cancel it, and I will fall back to default mechanism. I will just go ahead and fall back to my another default mechanism. If I'm getting this within this particular time, if I'm getting the response, then well and good, right? It's working just fine. But if I'm not getting, what I will do, I'll just have a fallback method and I will handle it here itself instead of waiting for this particular inventory service. So this is basically the very simple solution that I will design. And again, Spring Boot has already designed it and it is present inside Resilience4j library called as time limiter. Simple stuff, very, very simple stuff. So that is when time limiter comes into picture. Now what exactly is time limiter? Time limiter stops waiting for response once a configured timeout is reached. So once your configured timeout that we are talking about here reaches, then this particular request will be stopped and a fallback mechanism will be called. So that is basically your time limiter. So that is basically time limiter. And why do we need it? Again, as we have discussed while looking into this particular example, first thing is basically we will have thread blocked. Multiple threads inside your order service will be blocked. And as and when you are getting multiple requests, your thread pool will be exhausted. After that, your user on the other side over here, this particular client, is waiting on its computer screen to get all these responses because inventory service is taking a lot of time. So there will be that particular loading circle going on, which is a bad user experience. So it is a poor user experience. So that is basically second point. After that, again, same thing that we have discussed inside rate limiter as well, resource exhaustion. So there will be multiple resources which are being used when this guy is waiting for inventory service to send the response. So your resource utilization will be more. After that, your API will become slow. This guy will become slow and your client will get a response in delay. So there will be delay in the response. So all those problems, so we have all those problems, and in order to resolve this problem, we need time limiter. That is basically the need of your time limiter. We have seen the problem, we have seen what exactly is time limiter, and we have seen why do we need it. Now let's look into time limiter flow, right? Very, very simple flow. Let's try to visualize it over here. So here, if you see, we have this order service and we have this inventory service. So again, same thing that we have discussed. So whenever order service sends the request to inventory service, what will happen? A timer will be started. And before that, what we will do? We will configure a value. We will configure a threshold time before which we expect the response from inventory service. And after that, what we will do? We will check in this timer, is the request completed before this configured timeout? If the answer is yes, then we will return the response of inventory service. We will consume the response of inventory service inside order service. And if the answer is no to this question, which is the request completed before the configured timeout? If the answer is no, then cancel this request, cancel the request that we sent to inventory service and fall back to default method inside order service. How simple is that? Very, very simple stuff, right? And all these things all these things up to here are happening inside your order service. So this is basically the utility that is present inside order service itself. Inventory service is not aware of it. Inventory service is basically doing its job. It is trying to do its job and try to load the data for order service, but order service is in hurry. Order service wants the quick response, and if this guy inventory service is not returning quick response, this guy do not have any option but to fall back to default method. So all these things are basically handled by order service. Inventory service is just relaxing. So that's all is basically going on, and that is basically the simple flow of your time limiter. Very simple. This time limiter is very simple. Now before we move to implementation part, there is a very important thing that I want to call out. So basically timeout versus time limiter. Now let's say order service is talking to inventory service, and let's say inventory service is taking a lot of time. Then eventually after some amount of time, you may have seen the read timeout error or connection timeout error or socket timeout errors, right? So those errors will come over here. It's not like it is going to be forever. This connection is going to be forever there and your order service is going to wait forever until this guy returns. No, this connection will get disconnected at some amount of time, and that depends on the HTTP client that you are using. For example, Feign client, right? So we have been using Feign client inside our application. So this particular HTTP client is responsible for making this connection and fetching the data, returning the data. And if this particular request is taking a lot of time, then returning some error. Now there are multiple type of these errors. So first is basically a socket timeout error. Let's say first order service is sending this request to inventory service, and inventory service is waiting for a while, doing its job. A lot of time basically it is taking over there, and eventually this HTTP client, what it will do, it will see that this is taking a lot of time. So eventually this particular connection will time out, and this guy will return a socket timeout exception. After that, there is connection timeout as well. For example, when we send the request from order service to inventory service, first this HTTP client will try to get the connection on inventory service. If it is not able to get the connection, for example, if this guy is down, it will wait for like some amount of time, and after that it will send the connection timeout error that is not able to connect to inventory service. So that is basically other type of error that your HTTP client handles, because at the end HTTP client is responsible for establishing this connection and providing the response to order service. And this connection timeouts, read timeouts, everything we can configure inside our Spring Boot application. So all these things are basically going on inside your network layer. So this is basically the network layer of your application, isn't it? So all these things are basically happening at network layer, not inside your application. But if you think about it, what if I don't really care about this socket timeout? I don't really care about this connection timeout. I don't really care about read timeout. I don't really care about if this guy inventory service is taking a lot of time to run a database query. I don't care about what is happening. I don't care about if this HTTP client is unable to get the connection on this particular inventory service. What is my requirement as a user over here? What is my requirement as order service over here when I want to look into resilience? I want to stop this request the moment a time threshold value reaches. After 2 seconds, I don't really want to continue. I want to stop this request. That is basically my simple use case. I don't want to look into all these network specific stuff, all these different exceptions, all these different timeouts. I don't really want to do that. What I want to do, I want to handle this use case in application level. So that is when we move away from network layer and go to application layer and bring in our utility, which is time limiter inside order service. So now we will do this instead. So all these things will happen inside application layer, not at network layer. We will just monitor this time. We will check if it is responding within time. If not, we are just falling back to a default method. So this is happening at application layer, not network layer. So that is basically the major difference between the timeout of your HTTP client and the timeout of our friend time limiter. These are two different things. One is working on application layer, other is working on network layer. So that is basically the difference between your timeout versus your time limiter. A lot of people will get confused between this, and this question is pretty famous inside interviews, so you must be aware of that. Alright, so now let's move to implementation and demo part. Now if you remember, we have this ecom order service, we have Eureka server, we have inventory service. All the services are up and running. If you see over here, inventory service is down, so let me just start it. So let it start. So if you see, inventory service is started, this particular Eureka server is running, and here let me just look at it, and here you will see that our friend order service is also running. All right, now what we will do here, if you see, we have this particular inventory service which is sending the request to our ecom inventory service. So it is basically a simple flow. We have a controller inside which we have order / product ID. In order to place order, we will go inside place order. First we will do get inventory, and we will just decrease the quantity and update the inventory. So in order to do this particular get inventory, we have inventory service dot get inventory, and here we have this particular method, and we have seen retriable, we have seen rate limiter, we have seen circuit breaker over here. Now what I will do, I will comment this guy out as well, and let's try to implement our friend time limiter. Now again, time limiter is present inside Resilience4j library, so you need this particular library present inside your application along with Spring Boot starter AOP. So you need to add this particular dependency, simple dependency basically. After that, here if you see, we have been using this time limiter, rate limiter from this particular Resilience4j library itself. Now what I will do, similarly I will just go ahead and say add time limiter over here. So I'll say time limiter, I will just give it a simple name as, let's say, inventory service time limiter, and I will add a fallback method as well. Similar stuff, right? So instead of circuit breaker, I will just rename this guy as inventory, not inventory, let's say time limiter fallback. And what I will do, I will just give this name to this particular method. Let me copy this, and there we go, we have a fallback method ready as well, and that's it. Now what I will do, I will go to inventory service, and what I will do, when we say check inventory or get inventory, what we will do, we'll just add a thread sleep. So we already have it here, we might have used it somewhere, and we, instead of waiting 15 seconds, let's wait for 5 seconds. And now what I will do, I will just restart this particular inventory service after doing this change. So let it come back, and it is started. Now what I will do, I will just go ahead and add some inventory, and now if I try to place this order, then let's see what happens. Now here if you see, we are getting internal server error. Now let's go back and let's try to look into what exactly is happening. Now here if you see, we are getting a error, and it says get inventory has unsupported by time limiter return type, completion stage expected, completion stage expected. This is very, very important. Now here what we have done, we have just changed the circuit breaker to time limiter, but time limiter is not same as these implementations. Here it was just adding a annotation and that's it, but time limiter is different. Time limiter cannot be synchronous. All these things were synchronous, but time limiter cannot be synchronous. Now let me go over here to canvas and let's try to understand it. Now let's say you have a controller first, right? So from Postman, we are sending the request to controller. The request is going to order service. The request is going to inventory service, and inventory service is now calling this inventory client.getInventory. And now after that, what it will do, it will wait for response. And now if you observe over here, everything is happening inside a single thread. Now after this particular waiting, it will just give us the inventory object. So what it will give, it will give inventory object, that dude, this is basically the inventory, and we return this particular inventory from our function. So we return that from this particular function, we return this inventory. Now we cannot return anything from here until we have this inventory, because everything is happening inside a single thread. Everything is happening inside a single thread. So this is one thread only. This is one thread only, right? Controller, order service, inventory get inventory function call, going to inside your inventory service. So we are waiting over here, and after 5 seconds we will get the response. Now let's say we have a time limiter. Now this guy, we have this time limiter. Now if you think about it now, where this time limiter will fit in, how this time limiter would know that this particular inventory service is taking more time and everything is happening inside a single thread. How this time limiter can observe this time within this same thread. Time limiter cannot observe this time and it cannot interrupt in the same thread that dude, stop, 2 seconds are done. It cannot do that because it is a single thread. We cannot have any loop and stuff over here. We cannot really have timer over here in the same function. How you can do that? If you see over here, how can you see how much time this guy is taking? You cannot see inside a single thread, but you can do that by using another thread. So let's see how. Now here, let's say instead of returning actual inventory from this function, instead of returning this actual inventory coming from inventory service, we return a promise. We return a promise that dude, this is basically the object. This does not contain inventory, but once it is available, I will give it to you. That is called as promise. It is pretty famous inside JavaScript, but inside Java, we make use of completable future in order to do that, right? Now, in the same situation, let's see what we can do now for a same situation. Now, all these things we are doing because time limiter cannot see this particular time, cannot interrupt this single thread. Now, let me just paste it over here, same thing. And now what we will do, from inventory service, from this particular inventory, let me just remove all this. We create a completable future. From inventory service, we create a completable future. We start another thread. So this is basically your main thread that is going on, right? And we start from here, we start another thread. And here now we give what we can give over here. Here we can go ahead and make this particular call. Now this call we make inside another thread. So now here, what do we have? We have a background thread, which is running this particular call. And from here, what we are doing, we are returning a inventory object, which is basically a promise, which is kind of a dummy inventory. It does not really contain the inventory data, but the data will be available once this particular inventory client returns the data. And now your time limiter comes into picture, and now this guy can monitor this promise that if the data is available inside that specific amount of time. Now this guy is monitoring this particular promise because it is already returned now. The promise is returned. Now inside aspect where it got this particular promise, it will just check if the data is available. So it is basically checking the response of this particular thread. So let's say if within 2 seconds this particular thread is returning this data, then your completable future will have that particular data and time limiter will return that data. But if within 2 seconds, if this guy is not returning the data, then promise will not have that particular data. Time limiter will stop this particular call and it will just fall back to default mechanism. So that is how your completable future comes into picture, and asynchronous processing comes into picture, by using which time limiter can do its job. So the implementation is not going to be the exact same. What we need to do, we need to wrap this inventory object inside a completable future. So completable future of inventory, that is something we need to do now. Completable future of inventory. And while returning this inventory, we need to wrap this inside a completable future as well. So we can just do that completable future dot supply async, and we can just do this now. And we can remove that, and here we can simply return this. So what we are doing, we are just saying completable future dot supply async inventory client get inventory, and this is basically the same call. So we are just returning a promise, and this particular function will be called by using a completable future. And similarly, we will have to do it over here as well inside inventory service. So I will just go ahead and copy this particular thing over here. And here also what I will do, I will just go ahead and let me just catch it inside a variable. Let's say this particular inventory. And while returning, I will simply go ahead and make use of completable future dot complete future inventory. That means it is directly returning this object instead of doing any method call. So that is how this will work. Now the caller method also, if I go back over here, now this particular caller method also, we need to make use of join method over here in order to get the data, because that is something we need to do for completable future. Now what I will do, let me go ahead and stop and rerun this guy. And now let's see what is happening. Let it come back now. There we go. So our friend has been started. Let me go back, add some inventory, and now let me try to send this request. Now if you see what happened, now let's see what happened over here. Calling inventory service for product ID 1, and let's see what happened. Fallback method called immediately. It called after some amount of time because we have a default time over here. So if you don't really configure it, the default time for this particular configuration is basically 1 second. So what I will do, I will just go back over here and let's try to add the configuration for this particular time limiter now. So we already have a configuration for circuit breaker. We have rate limiter, we have circuit breaker. Let's add for our friend time limiter as well. So I'll just say time limiter. Let me check the indentation once if it is fine. No, it is not. It should be one level back. So let me just pull it one level back over here. Now it is correct. So inventory service and inventory time limiter, make sure your name matches this particular name. So let me copy it, paste it over here. Your time duration is going to be 2 seconds. Cancel running future. So cancel running future means this particular completable future that we are calling, our friend time limiter will cancel if this particular time is basically reached. What we will do, we will just go ahead and stop and rerun, and let's try to hit it again. So let it come back. So it started, and let's send it. Now it will probably wait for 2 seconds, 1, 2, and now it will fall back to our default mechanism. So it should be, this particular log should be printed. So let me just try to find it. So there we go. This particular log is basically printed. Now what we will do in order to test positive scenario, I will just go ahead and probably we can just go ahead and comment this particular timeout over here. We don't really want that. And now what I will do, I will restart this particular inventory service. So let it just come up. So now we have removed this particular timeout. And now what I will do, I will just go ahead and try to add some inventory first. And now what I will do, I will just go ahead and send this particular order. So I will just try to send this particular order. And now if you see, it will immediately be placed. And here if you will see, if I go back to ecom order service, then you won't see any fallback. So if I go back over here and try to search for this particular fallback method, you won't see any fallback. Because now in this case, there is basically no delay inside your inventory service. It is sending the response pretty quickly, within less than this particular 2 seconds. And as it is sending within this particular time, your time limiter will just return the simple response and it works. Now probably what we can do, let's try to keep 1 second over here, which is basically less than 2 seconds. And let's try again. Now what I will do, I will just rerun this ecom inventory service. And let me add some inventory again and try to send this particular order. Now here you will see after 1 second it is successful. It is successful after 1 second because time duration is 2 seconds over here. Now what I will do, I'll just stop and rerun inside a debugger. So in debug mode, I will just rerun it and I will go to inventory service. And let me just go ahead and try to put a debug point over here inside this particular get inventory service. And if I try to send it now, then you will see again we have this particular proxy. So this is basically a proxy. So again, your inventory service is basically using a proxy aspect-oriented programming in order to handle all this. Now what we will do, let's proceed and let's see where it is going now. Now if you see, it is going inside AOP utils, where it is basically invoking our friend, our method. Then we have this reflective invocation. Then we have invoke join point. After that, we have this method invocation proceeding join point. So it is going to this particular time limiter implementation. This is basically the time limiter implementation. Now these are basically internals. Now here if you see, we have this completable future. Now the completable future returned by our method is coming over here, and this is basically the future it is returning. And now your time limiter will come into picture. It will create a timeout future, and it will, now what it will do, now our time limiter comes into picture, this time limiter inside this particular proxy. So this is a proxy is handling this time limiter implementation. And now here this time limiter will monitor this particular future. So now it will just check, when complete it will just return the result. And what it is doing now, it is checking for timeout as well. If timeout is not done, then it will just cancel this particular request and it will fall back to the default implementation. So that is where your internal working is basically going on. Inside proxy, all these things are being handled. So that is basically how your time limiter also works on a proxy based approach. So everything is working on AOP, but the implementation of your time limiter is little different because it needs asynchronous processing by using completable future. So that is basically your time limiter. So we have seen implementation, configuration and demo as well. So that was fun. Again, if you look at it, it is basically very easy stuff. It's just that what we need over here is, what is different over here is just this particular completable future. So we have seen time limiter as well. So that's basically it about time limiter. We have successfully seen time limiter. So that is basically completed. Now for the next section, let's look into BulkHead pattern. Now BulkHead is again important pattern. So let's look into it. And again, we can simply implement that by using Resilience4j. So BulkHead in Spring Boot microservices using Resilience4j. So BulkHead is again present inside Resilience4j. First, we will look into what exactly is the problem. After that, we will see what exactly is BulkHead. After that, we will see why it is called as BulkHead in the first place. After that, there are a couple of types of BulkHead, semaphore and thread pool. So we will look into both of these, and simultaneously while looking into each type, we will look into the demo part as well. So that is basically the simple agenda. Now let's get started with the problem first, and before moving to that, let's recap. So we have seen retry pattern. Retry pattern will help you with temporary failures. After that, we have seen rate limiter. If we are sending too many requests, that will basically create a problem. So it will protect against too many requests. Circuit breaker, persistent failure, it will protect against persistent failures. A time limiter, it will protect against slow services if your service is taking like forever to respond. After that, what exactly is the use of BulkHead? That is something we will look into. After that, let's try to understand the problem first. So now if I go back to Canvas, then this is basically two services that we have been looking into in this particular playlist. So we will have order service, we will have inventory service. So client will send the request, it will go to API gateway, it will go to order service, and order service will call inventory service in order to get the inventory. And if the inventory is available, it will just go ahead and place the order. So that is basically the simple flow. Very simple flow. Now let's say there are multiple clients and clients are sending parallel requests to order service, and order service is sending parallel request to inventory service. Now let's say inventory service becomes slow. Now when services became slow, time limiter is basically one of the option. Time limiter is one of the option for slow services to fall back to some kind of default mechanism. But even before checking the timeout, let's say we are sending concurrent requests, right? We are sending concurrent request from here. These are all the threads present inside your order service. Now let's say if inventory service is taking, let's say 10 seconds to respond, it is processing for 10 seconds, then all these three resources are blocked for 10 seconds. Then all these three threads are basically blocked for 10 seconds. And now let's say there is another thread comes, that thread will also be blocked for 10 seconds, right? Now let's say we know that inventory service can only process two threads simultaneously. More than two calls, if we are sending simultaneously to inventory service, it is taking more time to process. Now we know that if we only send two concurrent requests, then this guy will just work fine. But if we send more, then it will create problem. Now that is something we know. Now let's say there are 10 requests coming simultaneously and we send all 10 to inventory service. Now all 10 threads will be waiting for the response from inventory service. Well, that is the problem. But what I could have done, I could have just sent 2 and rejected other request, which would have been a better choice, and inventory service could have returned the result. After that, I could just send 2 other requests after a while and that would also have worked. So that is basically one solution to this problem. Now let's say there is another service. Let's say what service? Let's say notification. Now notification service will return responses quickly. If we send the request to notification service, it will return the response quickly. This guy is fast basically. But now let's say we got 10 requests to inventory service. We only have 10 threads. Inside order service, we only have 10 threads. We have a thread pool. Let's say we have a thread pool. We have a thread pool inside order service. We have thread pool, and this thread pool contains 10 threads. Let's say this thread pool only have 10 threads and we got 10 requests from this particular client, and all the requests are for inventory service, and inventory service is basically waiting for 10 seconds. Similarly, we got another request for notification service, but this notification service request will now fail because all 10 threads inside this thread pool are basically waiting for response from inventory service. That is basically another problem, because now your another service request, even if it is faster, it will get failed or rejected. That is again another problem. So now there are 2 problems that we have seen. First, your thread pool getting exhausted and another service call which is actually faster will not even get any request. And first problem, inventory service can support 2 concurrent requests, but anyways we are sending more. That is again another problem. If we manage to only send 2 concurrent requests at a time, things will just get resolved. So first problem is basically concurrent request. And second problem over here is thread pool getting exhausted. So these are basically the 2 problems that we are facing over here. Now let's talk about first problem. Let me just pull this notification service over here. Let's talk about first problem. Now what I can do here inside order service, I can add a utility. Let's add a utility. Let's say first utility. Now what this utility will do, it will handle the concurrent request. From order service, if we are sending concurrent request to inventory service, what we will do, we will limit the number of concurrent requests. That means we will only send 2 requests. If third concurrent request is coming, then what we will do, we will reject that, or we will ask it to wait for, let's say, some amount of time. Like these 2 can wait for 5 seconds, and whenever these 2 threads are completed, we can just go ahead and send these 2 threads. Like that we can do. So that is how I can simply solve first problem. How about the second problem? Now the second problem is that your thread pool is basically being exhausted and notification service is not getting any thread. Inside your thread pool, I can, let's say, allot 3 threads dedicatedly to inventory service. Now thread pool inside order service have 10 threads. Among those, we only allocate 3 dedicated threads to inventory service, and other threads can keep serving the other services that you might having, like notification service or let's say payment service or whatever service, so that we are not sending all the threads to inventory service itself and they are waiting. So by using these 2 utilities, I can simply solve this problem, isn't it? Very simple stuff basically. Now these 2 solutions are present inside a single resilience pattern which is called as BulkHead. That is basically BulkHead. BulkHead totally focuses on your concurrent request. BulkHead totally focuses on your resource exhaustion. Your threads should not get exhausted just serving one service because it is slow when we send concurrent request to it. That is basically the problem your BulkHead is trying to solve. So now you will see the difference between BulkHead time limiter and rate limiter. Rate limiter will handle too many requests. Time limiter will handle slow services. It will just time out after some amount of time. But BulkHead, what it will do, it will handle your resource exhaustion. It may happen that by using BulkHead, you can just manage 2 concurrent requests and you don't really have to fall back to your default mechanism each time, as we do inside your time limiter, inside your rate limiter. Time limiter, time exhausted, you just fall back, right? But here it may happen that 2 requests are basically being served parallelly. 2 requests are present inside queue or waiting for getting this particular permission. So once these two are done, these two can get permission and they will just work. So like that, you don't really have to fall back to default mechanism. But in worst case, if these two requests are taking a lot of time, then you may have to go ahead and fall back to default mechanism inside order service as well. So that is basically how your BulkHead works. Now what BulkHead will do? Let's go through the definition. So BulkHead isolates resources so that one failing or slow component cannot consume all the resources and affect the rest of the application. Makes sense, right? It isolates resources. That means it is isolating these two concurrent threads or just dedicating 3 threads to this particular service so that one failing or slow component cannot consume all the resources. All these 10 threads, this guy should not consume and affect the rest of the application. So it is basically isolating your defective part and your rest of the application is working just fine. So now your only 3 threads are impacted or just these 2 concurrent threads are impacted in this case. So that is basically what we call as BulkHead. And why it is called as BulkHead? It has a famous analogy, very famous, very popular example of, let's say, a boat. So let's say this is basically the ship. So this is basically the bottom of your ship. Bottom of your ship. Now this ship have, let's say, 4 compartments. Ship is basically moving into this direction, let's say, and it accidentally hit some kind of rock. And now water is flowing inside your ship through this particular hole. Now ship have many compartments. Now since water is flowing inside your ship, this part will fill. After that the water will go into next part, it will go into next part, it will go into next part, and whole ship will basically just sink. But how do we handle it? If this particular part is broken, water is going inside, what do? Isolate it. We isolate that particular part and water will only fill inside this particular compartment and all other compartments will be empty and your ship will not sink. Now here ship is basically your order service and we are only isolating these particular threads which are impacted or these 2 concurrent threads which are impacted. All other threads are basically working and serving other requests. So we are isolating only affected threads, affected area inside your ship. And now this is basically the head of the ship which is basically isolated. And now based on this analogy, we call it as BulkHead. So that is basically the analogy and that is why we call it as BulkHead. So very, very simple stuff basically. So we have understood the problem. We have seen what exactly is BulkHead and we have seen why it is called as BulkHead. Now let's proceed and let's look into the type of BulkHead. Now we have discussed 2 problems over here. One with concurrent request and another with your thread pool being exhausted. And these 2 problems are basically solved by these 2 type of BulkHead. First problem will be solved by first solution which is called as semaphore BulkHead. Second problem will be solved by second solution which is called as second type which is called as thread pool BulkHead. So let's look into the first type. This is basically first type. Now what we will do, we will just go ahead and make use of BulkHead inside order service and each request will have a permit. So we are sending a request to inventory service. Each request will have a permit. So first we will check if the permit is available to send this particular request. If the permit is available, we will just execute that. Otherwise we will reject. Now while we reject, we have 2 options. We have an option to wait for some amount of time so that let's say if this particular request is executed quickly, then this guy can get a permit. So some amount of time we can wait or we can just fall back to a default mechanism. Similarly, what we have been doing in other resilience patterns. That is basically a simple stuff. So here what we will do, we'll just configure maximum concurrent calls. So we'll just say maximum concurrent calls. I just want 2. So let's say first request come, it will get permit, it will get executed. Second request come, it will get permit, it will get executed. Third concurrent request come, it will get rejected. Now it can wait for some amount of time. How much amount of time it can wait? It can wait something like, let's say, maximum wait duration we can give. And it will just wait for, let's say, if I say 0 second, then reject immediately. If I say 1 second, then it might be the case that this particular request was completed within 1 second. And when we rejected third request, it waited for that particular 1 second and got the permit again because that permit was released and your request got executed. So like that, we do in semaphore. So that is basically how your semaphore works. And all these things are basically happening inside your order service. This is basically the logic of your order service. Inventory service is not basically aware of it. So that is basically how it will work. Now what we will do, let's jump into the code. Let me just bring in my IntelliJ. So this is basically your ecom order service. This is Eureka server, and this is basically inventory service. And we will see that everything is basically running. And here, if you see, we have inventory service, and inventory service, what it is doing, we have a circuit breaker. So this is basically circuit breaker implementation that we have already seen. Now what we'll do, let me just comment it out. We don't really want circuit breaker over here. Now here, if you remember, we have a get inventory method, which makes use of this inventory client. This is basically Fein client, and which is get inventory. And it will go to our friend Fein client. So here, if you see, we have inventory client, which is a Fein client. So ecom inventory service is basically the name. This is basically Fein client, and which will go ahead and do your call to inventory service. Now, if I go back to inventory service, then here you will see that this is basically the call that we are making. And what I can do now, let's just go ahead and add some delay in order to test our BulkHead stuff. So let's say 10 seconds basically. And let me just restart this guy, stop and rerun. Our inventory service is back. After that, this is basically the order service. And here what we will do now, we will just go ahead and restart this particular application once. Let's see what happens. So now if you see, we don't really have any resilience pattern on top of our get inventory. We don't really have any resilience pattern. So there should not be any fallback basically. And now what we will do, let me go to Postman, and let me just go ahead and add some amount of inventory, let's say 50 units. And let me send a order. So I'll just quickly send the order. Now it will wait for 10 seconds, because here inside order service, we have given 10 seconds sleep, right? So we have given 10 seconds sleep. So now let's see what is happening inside our application. Let me go to order service. And here, if you see, we are getting some amount of errors. So here, if you see, it is retrying. Who is retrying? Do we have any retry? We don't really have any retry over here. This is commented. Who is retrying then? Here, if you see, it is getting socket timeout exception, and it is basically retrying again and again. So now there will be a question on who is retrying this stuff. Who is retrying? 3 retries I'm just seeing, and after that it might have just given an error, which is socket timeout. So someone is retrying. Who is retrying? The answer is this particular inventory client that we have. This guy will have a default retries. This guy will have retries, and if inventory service is taking a lot of time, this guy will automatically retry. Now before we test our logic, we need to disable this retry of Fein client, right? So what we can do, I can just go to application.yaml, and let's see if we can disable this particular retry. So what I will do, I will just add this configuration, which is Spring Cloud Open Fein client config, your ecom inventory service, and connection timeout, read timeout I have just increased. So read timeout I'm just increasing to, let's say, 30 seconds, and our inventory service have basically 10 seconds. So now this should return us the result without even retrying and failing anything. So now what I will do, let me just restart this particular application and let it come back. So it is started now. Let me just send this request, and now within next 10 seconds we should get the response. Let's see what is happening in this case. Now here, if you see, are we seeing any retries? No, we got the response after 10 seconds and our order is basically placed. So no problem basically. And so we have disabled that. Now we can move to BulkHead. So now I can just go over here and add annotation over here, which is called as BulkHead. I can just give it a name, and I can just fall back to, let's say, not circuit breaker fallback method, let's say BulkHead, not breaker, BulkHead fallback method. And let me just give the same name to our friend fallback method, this particular fallback method. So here I have updated this print statement so that we get product ID and thread name inside the log as well. And here also in the fallback mechanism, I have updated this particular print statement to print our friend this particular thread name as well. And here, if you see, this particular BulkHead is now coming from GitHub Resilience4j BulkHead, which is basically the library present inside Resilience4j. So here if you see, you need this particular Resilience4j library present inside your application in order to make use of BulkHead. So now we have added this BulkHead. Now how many concurrent requests you can have? That is something we need to define. That is something we need to define in configuration. So these two configurations we need to define inside application.yaml file. So what I will do here, we have this inventory service circuit breaker, right? Circuit breaker configuration. Similarly, I will add BulkHead configuration. So here what I will do now, here just below our friend, let me just go back to this place and add this particular circuit breaker. So this should be in this particular line. So BulkHead should be in this particular line instances, and this inventory service BulkHead name should match the name of your BulkHead present inside your get inventory, which is basically matching. After that, max concurrent calls, let's keep it as 2. Max wait duration, let's keep 0, so that it immediately rejects the request. And now if you remember what will happen, this particular get inventory will be called by using this particular place order method. Once we get the inventory, we just go ahead and update the inventory. Also in the get inventory, third call will be rejected and the fallback method will be called. Now here we are returning just 0 quantity, and what will happen if the request is rejected, if the fallback is called, we will return the 0 quantity from here. And since the quantity is not greater than 0, we should get product out of stock. And here if you remember, we are updating the inventory. Also here if you see, since we are sending 0 inventory, it should not just go ahead and update the inventory to, let's say, -1, because we are decrementing 1. So what I will do, I will just go ahead and add a if case over here, saying if get quantity is less than equals to 0, then let's not throw any exception. We don't really want to throw any exception. Just go ahead and return from here. We don't really want to do much over here. Now what I will do, I will just go ahead and stop and rerun. Now let it come back. Now let's see what happens. Now remember, here we are permitting 2 parallel requests, and third one should get rejected. Now let's go ahead and let me go to postman, and here if you see, now I have copied the same request 3 times over here, 3 times. Now let me just send the first one. So it has been started. Let me send the second one. So 2 requests are running in parallel now. Now let me send the third one. Now here if you see, it immediately got rejected. Other 2 are still going on. See, one got successfully completed, second also got successfully completed within 10 seconds. So that is what is happening. So third request got failed. Now it should have went to this particular BulkHead rejected. So this message should have been printed only once. Let me just try to copy this message, find it over here. Then you will see that BulkHead rejected, reason BulkHead exception. After that, let's try to just query this particular method, this particular call. So here if you see, so these 2 threads are running basically in parallel, and for third thread, this was not executed, rather your fallback was executed and this particular message was printed. So that is basically simply how your BulkHead works. This is a semaphore pattern. Here inside BulkHead, if you just go inside BulkHead, then there should be a type. So here if you see type, and default is semaphore. So by default it will have a semaphore type. If you want to change it, we will see how we can change to thread pool in a bit. So by default is semaphore. So we have seen the semaphore pattern, and that's how it works. Here we are just only allowing it to execute 2 parallel requests. Now what I will do, what we can try probably, let me just go ahead and increase this max duration to 10 seconds. Now let me just stop and rerun. Now third request also should get the log, because one of these will get completed within 10 seconds and the third one should also get the permit. Now let me just go back. Now observe carefully. I will just send the first request. So let couple of seconds passed. I will also send the second request. Let couple of seconds pass, and let me send the third one. Now here if you see, it is not immediately returning the response. Rather it is waiting for these 2 to get completed. Now let's see. Now here one got completed. Now this request over here also got completed because it got locked. and all these 3 requests are got completed now. So these 3 requests got completed and none of them failed because we have added this particular max duration. And that is when bulkhead pattern is helpful because it minimizes your fallback. It may happen that these two get locks by using this particular wait duration. So that is when bulkhead pattern is different from your time limiter or rate limiter. So that is basically your semaphore pattern. So now we have seen semaphore bulkhead completed. Now let's quickly look into thread pool bulkhead. Now let me go back over here. This basically solves this particular second problem where other service was not getting any resources, not getting any threads. So what we did, we give dedicated threads to this particular inventory service. Now let's see how we can do that. Now let's say order service is sending request. So first, when we send the request to order service, we will first check if the thread is available. So let's say we have given a dedicated threads, let's say 3 dedicated threads we have given to this guy. And now what we will do, we will check if the thread is available. If it is available, then we will just go ahead and execute. Otherwise, we will reject. Now, while rejection, we will either go to a fallback or there will be a queue. So we can just define a queue size. Let's say queue size is basically, let's say 1 over here. Then what will happen? It will just go ahead and wait inside queue. And whenever a thread is available, it will just get consumed. So that is basically something which is new inside your thread pool bulkhead pattern. Very, very simple. All these things are again happening inside your order service, and this particular size, this size, and this size we can configure. We can easily configure that. So majorly there are basically these 3 configurations. So first we have max thread pool size. Let's say max is basically 3. That means dedicatedly to this particular inventory service call, we have just given 3 size from whatever pool we have inside our thread pool executor. And core thread pool, that means there will be a one primary thread which will just be doing all the work, and your thread pool can expand to 3 threads if there are more load. And that means maximum 3 threads can be allotted to inventory service. In your application, you will have many threads, but among those, only 3 threads are basically allotted to this guy. Queue capacity, if the queue capacity is 0, then the request will be immediately rejected. Otherwise, it will just go ahead and be inside queue. That means it will wait for other threads to get free. And for the implementation is again simple. So let me just go back to inventory service. First thing you need to do is just change the type to bulkhead type thread pool. After that, here thread pool bulkhead is specially designed for asynchronous processing. So in order to do asynchronous processing, I have given completable future over here. Similarly, what we have done inside time limiter, and I'm wrapping it inside completable future, basically simple stuff. After that, here if you see, our fallback method also is wrapped inside completable future. And if I go back to get inventory, I'm just doing get inventory.get over here and throwing the interrupted exception over here inside method call, so that everything is in sync. And this is basically our fallback method now. And inside our application.yaml, I have also added this particular size. So max thread pool size is 3, core thread pool is 1, so this is basically primary thread, and queue size is 0. So 4th request should immediately get rejected. So now what I will do, let me just go ahead and stop and rerun this particular application, and let's see a quick demo. So let it come back. So it has been started. Now let me go to Postman. Now let me just send the first request. So it has been started. Let me send second. Let me send third. Let me send fourth. Now here if you see, fourth gave me an error. Why fourth is giving error? Let's see. Let me just go back and let's see what error we got over here. Did we get any error? There we go. It says bulkhead inventory pool is full and does not permit calls. Alright, but there should be a fallback method, right? It says no fallback method match found. So there must be a mistake while I added this particular fallback method. So it says bulkhead fallback method. The name seems to be different. So let me just copy this name and paste it over here and restart this particular application. So let it come back and it has been started. Now let's start again. Let me send the first request. Let me send second. Let me send third. Let me send fourth. So fourth said product out of stock. And let's try and see if this fallback message was printed. So if you see, one message was printed which says BulkHead exception. Simple stuff basically, because all these three threads are processing at the same time and fourth got rejected. And now if I just go ahead and increase the queue size to, let's say, 1, then one request can wait inside queue. So let me just restart and let it come up again. And let me just send this request. So let me send the first one, let me send the second one, let me send the third one, let me send the fourth one. Fourth one is now again running. Let me send the fifth one. Now fifth said product out of stock. Now fourth one is again running because it is inside the queue. Now earlier request got succeeded, so this might have got the thread and now it is started processing. Now it may get processed like so. It got processed in another 10 seconds. Now if I go back, then here let me try to find the same log. You will see it was printed once because only one was basically running in a fallback. Now again this guy runs on a proxy based approach. Now here if I add a debug point, let me just send it again. Now here if you see, this particular call is wrapped inside a CGLIB proxy. CGLIB proxy basically. So inside your service and inventory call, we have 18 hidden frames which contains proxy. Similarly, as we have seen, let me just proceed and let's see what is happening now. Now it will wait for 10 seconds to get the data from our friend inventory service. After we get the data, we will see where the call is basically going. It should just go inside a proxy. Let me just go back. Now here if you see, it is coming inside AOP utils. It's going reflective method invocation. Let's proceed where it is now. Now here if you see, it is inside BulkHead aspect. Now this is basically the aspect which handles all the BulkHead related things. So it will just go ahead and make use of this particular thread pull BulkHead. It will check the size, it will execute, it will catch the exceptions, and it will handle everything. So all these things which are happening in between are basically handled by this particular BulkHead aspect. That is how it basically works on a proxy based approach internally. So that also we have seen. So we have seen the thread pool BulkHead and we have seen the demo part as well. Now let's quickly look into the difference between rate limiter, time limiter and BulkHead. People basically get confused between these three. So rate limiter prevents too many requests. So the purpose is basically for too many requests. Time limiter is basically waiting too long. That means in a fixed interval of time, if the request is waiting too long, just go ahead and fall back. BulkHead prevent resource exhaustion. Your threads should not get exhausted. That is basically the job of BulkHead. Rate limiter controls request over time. Time limiter controls execution time, and BulkHead controls concurrent executions. So it is like rate limiter is like we can only send max 10 requests per second. Time limiter says timeout after 2 seconds. BulkHead says maximum 5 call at once. So totally BulkHead comes in picture when it comes to resource exhaustion and concurrency of your threads. That is basically a simple difference between these three. So we have seen that one as well. So we have seen BulkHead. Now let's go back to our big picture. So we have seen the BulkHead pattern as well. So we have completed everything. We have looked into each section. Now all the code, all the branches and everything, all the GitHub repositories you will find in the description. You can just go ahead and check it out. You can just go ahead and try out resilience and fault tolerance on your own. So we have covered all this topic in a single video, and that is basically an essential part of microservice architecture. So that is basically it for this particular video. If you like the video, hit the like button. Don't forget to subscribe to Code Snippet. Share this video with your friends so that they are also aware of resilience and fault tolerance patterns inside microservices. So that is basically it for this particular video. See you in the next video.